Okay, this video is about how to calculate the density of a gas at STP or at different conditions, like in the room or wherever. All right, so the first thing you need to know is the formula for density. Okay, density is equal to mass over volume. Okay, and with gases, normally to do a density, they want the mass in grams and the volume in liters. Now you can do it in different units, but that's generally what they want. All right, so the first thing that you're going to do to figure out the density at STP of any gas is you just assume that you have 1 mole of that gas. And if you assume that you have 1 mole, all right, so like if you assume that you have 1 mole, well, 1 mole of any gas at STP equals 22.4 liters. So in the density problem, you automatically have the liters is 22.4 liters. And then all you got to do is get the molar mass of the gas, which CH4, well, the mass of 1 carbon is about 12 grams, so that's 12. And you have 4 hydrogens. The mass of one hydrogen is about 1, so that's 4. 12 plus 4, that's 16. So you take the mass, so you just assume 1 mole, and you get the mass of 1 mole, which is the molar mass, and you're going to divide that by the 22.4 liters, and so the density of methane at STP is about 0.71 grams per liter. Now you can change to any conditions you can use the same density formula, but there's a couple changes that you have to make. So I'm going to come over here and I'm going to write that density formula again. Density equals, oops, I'm running out of room here. Let me scoot over a little bit. Density equals the grams divided by the liters. So the density is going to equal the grams. Okay, well, if you assume 1 mole still, you're still going to have 16 grams. But what's going to happen is the conditions, if you change to these conditions, your volume is going to change. So what I like to do is you're still assuming 1 mole of the gas, but you're going to do this PV equals nRT math problem to see what your volume would be at these conditions instead of STP. So I'm going to rearrange this PV equals nRT for V. So V is going to equal nRT over P. Now I can plug in the numbers. V is equal to, well, we're assuming 1 mole, so N is 1 mole. R, okay, so for millimeters of mercury, the R value is 62.36 or something like that. It's close enough. Those units are going to be in millimeters mercury times the liters over moles Kelvin, that's a unit, times T. Well, we got to change our 22 to kelvins by adding 273. 5, 9, 295, so that's 295 Kelvin. Then we're going to divide that by the pressure that they give us in the room or wherever it's at, 765 millimeters mercury. And so when I do that, my new volume is 24.05 liters is what I get. So now I can come over here and I can plug the new volume, because density is the grams divided by liters. I can plug my new liters in here, and I can take the grams divided by liters, and the density that I get after doing that is around, I believe, 0.66 grams per liter, if I did the math right. All right? So let's do, you can pause the video and try this next one, but then you can replay or push play and see if you did it right. Okay, what is the density of C3H8? Okay, that's propane. So remember, density equals mass over volume, so it's going to be the grams over the liters. So we're going to assume 1 mole. And if we have 1 mole at STP equals 22.4 liters. So that's where, when I do the density equation, I get the bottom number to be 22.4 liters. I just got to get the molar mass of C3, so 3 carbons times 12, that's 36. And there's 8 H's times 1 is 8. So 36 plus 8 is 44 grams. Okay, so the molar mass is 44 grams. So the density is equal to 44 divided by 22.4, which I believe is 1.96 grams per liter. Now, I could change that density to room conditions by just using the ideal gas law. I'm still gonna do the density formula, the grams over the liters. But if I assume 1 mole, the grams isn't going to change. That's still going to be 44 grams. All right, but I got to divide that by the new liter. So I come over here and I'm going to do a PV equals nRT. I'm going to solve for V by moving P's got to go over here, my bad. So V, the volume is what's going to change. That is going to be nRT over V. RP, excuse me. All right, so V is going to equal N, where we're still assuming 1 mole, or 1, I guess I don't need a 0.0, but anyway, times R. Okay, so with R, it's 0.08206 is the atmosphere number. R number times liters divided by moles Kelvin. Times T, well, we got to work in Kelvin, so I got to add that up, 297 Kelvin times 297 Kelvin. Divide that by the new pressure, 1.06 atmospheres. All right, let me push the buttons here. So let's see here, 0.08206 times 297 divide by 1.06, and I get 22.99 is what I get. If we went off this thing to 3 significant figures or 2, however you want to do it, it looks like it's about 23 liters. Okay, so that's going to be divided by 23 liters. So density is equal to 44 divided by 23. And I get around 1.91. So it changed a little bit, grams per liter. Okay, that's how you get the density of a gas at STP and at conditions other than STP. That's it for this video.